It was a quiet day outside Eric's house, until a friend came to visit. His old friend Lucky was on the door, ready to go on and on about an over-explained topic. Node.js. Node.js is an open-source and cross-platform JavaScript runtime environment. Uses the single-thread even-loop architecture to handle multiple clients at the same time. Looks like Rex doesn't want to hear anything about it. But well, we want to hear you. We know about Node.js, but we hope that will be more fun with docs teaching us. Let's start with a brief overview of the key points to keep in mind about Node. Node.js is an open-source and cross-platform JavaScript runtime environment. It's a popular tool for almost any kind of project. It's hosted by the OpenJS Foundation and was released in 2009, created by Ryan Dahl, the same that creates Dino. Use npm as its package manager that gives the possibility to use third-party packages in a list of thousands. Runs the V8 JavaScript engine, the core of Google Chrome, outside of the browser. This allows it to be very performant. And now, keep in mind this because it is important. Outside of the browser. Thanks to this, it's possible to execute JavaScript code on the server side. Runs in a single thread called event loop that is able to manage multiple requests at the same time. This gives the possibility to handle queries asynchronously without blocking the main thread. That's all. We promise that all the information gathered here was in a ChatGPT's phone. Or at least not all. With the basics in mind, let's dive into some questions. How does it work? And what are the pros and cons of using it? To understand how Node.js works, we need to recap something that we said earlier a couple seconds ago. Handle queries asynchronously without blocking the main thread. Take a look to this scenario to get what we're talking about. Imagine that you get a line at bank and you only want to withdraw some cash. Fast operation, right? Yeah, but you need to wait for it to be your turn. And the line is big, so it will be a good idea to take a breath and be patient. The question here is there a way to make this faster? And the answer is yes. But first, we need to know about three concepts: synchronous, asynchronous, and multithreading. The current state of our bank line is synchronous. That means that the bank teller can only perform one task at a time. This is not a big issue when the client doesn't have any problem wait. But if this task takes several minutes and more requests come to the teller at the same time, this one will not do anything else besides wait. In an asynchronous system, our teller poly will perform another task while she waits for the first one to end. Once the first task ends and the teller isn't doing another one, they will finish the process. Looks cool, right? Until someone comes up with a process that needs the complete attention of the teller. The multi-threading system only wants to add more tellers. In this way, all the work is distributed and more clients are served at the same time. The problem here? Well, all the bank resources are shared. So if two tellers want to use the printer at the same time, we will have a problem. Okay, but how does this explain how Node.js works? Well, Node.js works like a band that has only one teller, the event loop main thread. But this one is not alone. It has a lot of mechanisms and other tellers that helps to get the work done. Let's take a look. The three most important workers in this bank are the VA engine, event loop, that is actually part of libuv, and libuv. That, by the way, is a multi-platform support library that helps with asynchronous input and output operations. Inside Node looks like this. We'll call single main thread to the dot green line, although it's not so single. You will see what we're talking about. Some instructions go inside Node. The VA engine throws these ones on the call stack. That is a last in, first out structure. The VA engine, on charge of run JavaScript code, execute the instructions. every of these one synchronously, at least that you force it to wait or need that a task will be doing asynchronously. For the async task, our friends can help to execute it. This task will return a callback to BA engine when they finish. BA executes this JS code included in the callback functions and deliver an answer to that request. Let's put some examples. In this test, the code is fully JavaScript, so the BA engine can handle it without any problem. But what happens if we add time? BA executes the sentence and even loop help to manage these timeouts and intervals. Okay, let's level up this. The function newClient and newTransactions use the FS model and made some queries to the database. libuv come to rescue in this case. If even loop cannot handle a task without blocking the main thread, send it to the libuv thread pool for be executed asynchronously using an extra thread. This is why we say that Node under the hood is not a single thread server. Once libuv finishes tasks, send a callback into the event queue structure. That is actually not a queue, but we're gonna use that term for simplify. Event loop constantly check it for new callbacks. Once get one, send it to the BA for execute the JavaScript code. And the cycle is repeated until there is not work to do. In a brief, Node.js is, indeed, single thread, but not for all the cases. Instructions entered to Node, goes to the call stack and are executed. For example, a console log. If a task will be asynchronous and requires a lot of time to be executed, it will be managed for even loop, using some operated system utilities like KQ on BSD or epool on Unix systems. One example of this is the HTTP module. Other ones are executed directly on libuv with a thread pool depending of the task type. These are some DNS operations that are blocking, file, system, crypto, and cellib API implementations, and also some modules that use C++ add-ons. Other way to visualize is this, when the unicorn step are all the async executions. Node.js is a great tool for developing web application, but all that glitter is not gold. Let us start with the disadvantage of using Node. First, it is not good for perform CPU-intensive operations. As we mentioned earlier in this video, Node.js scales pretty well and is so fast because its main thread never blocks, or at least try to not block it. If you use the main thread for complex operations like mathematical calculation, 3D rendering, or scientific simulation, you could block it. This doesn't mean that Node can perform these use cases, but definitely is not the best way. Another disadvantage is the quality and maintenance of NPM packages. It is funny, because having the disponibility of 1,000 packages will be considered an advantage. The problem comes when you use packages that are near to being deprecated because of an upgrade or simply because the developers behind decide to not give more support. Now, we're gonna mention the good things about Node. First, JavaScript everywhere. With the implementation of Node on the server side, a JavaScript developer can be full stack with only one language. This reduces the learning curve for understanding a complete system and allows the developer to be more efficient. Node has amazing real-time capabilities. This is because it's really fast compiling JavaScript thanks to just-in-time compilation mechanism of BA engine. And because of its asynchronous, non-blocking, and single-threaded features, it is a good choice for performance-intensive apps like chats or video games. Have a great scalability for the same reasons, and additionally, is able to scale horizontally. That gives you the possibility to manage hundreds of thousands of requests. In a conclusion, Node.js was and is a game changer in web application development, thanks to his efficiency and speed handling multiple requests asynchronously with all the mechanisms that we explain here. Also that is a very demanding framework in companies around the world. If you haven't had the opportunity to develop in Node, give it a try.